Good morning everyone. So actually we were discussing about the constructions of the quadrilaterals. So before going to that topic, we should know what is a quadrilateral, what are special types of quadrilaterals and their properties. Okay. So now what is a quadrilateral? It's just so easy. Quadrilateral is a polygon made up of 4 line segments. Okay. So what is a polygon? Polygon is a closed curve. So if I draw like this is A, B, C, D. So it is a closed curve and it is made of 4 line segments A, B, B, C, C, D and D, A. So this is a quadrilateral. So quadrilateral is just a polygon made up of 4 line segments, and the sum of all interior angles of a quadrilateral, that is angle A plus angle B plus angle C plus angle D, is equal to 360 degree. Okay, so a quadrilateral is a polygon which is made up of 4 line segments, and all the sum of all the interior angles is 360 degree. Okay, now we are going to discuss some different types of quadrilaterals, some special types of quadrilaterals and their properties. So the first types comes trapezium. The first one is what? Trapezium. So a trapezium is a quadrilateral in which one pair of opposite side is parallel. At least one pair. If in a quadrilateral, suppose if I draw like this, so in this A, B, C, D, this AB is parallel to CD. So whenever in a quadrilateral at least one pair of opposite side is parallel, then it is a trapezium. It doesn't matter about the other pair of opposite side. If in a quadrilateral there is at least one pair of opposite side is parallel, then it is a trapezium. Okay, and if this non-parallel sides becomes equal, non-parallel sides like BC and AD, they are not parallel. So if this non-parallel sides become equal, it is known as the isosceles trapezium. I can draw this trapezium like this also, like this. This is A, B, C, D. So in this AD and BC are parallel, and this AB and DC are parallel. Okay, so a quadrilateral in which one pair of opposite side is parallel is known as the trapezium. Understood? Okay, so now the next one. What is the next one? Next one is a parallelogram. Trapezium was in which one pair of opposite side is parallel, but in parallelogram is a quadrilateral in which both pair of opposite side is parallel. This is a trapezium. So if I draw like this one, A, B, C, D, in which this AB and CD is parallel and BC and this AD is parallel. So it is a parallelogram because in this both pair of opposite side is parallel. So a parallelogram is a quadrilateral in which both pair of opposite side is parallel. Okay, a parallelogram is a trapezium also, because for trapezium we need only one pair of opposite side, but in a parallelogram both pair of opposite side is parallel. So a parallelogram is a trapezium also, but a trapezium is not a parallelogram, because for a parallelogram we need both pair of opposite side, but a trapezium has only one pair. Okay, so a parallelogram is a trapezium, but a trapezium is not a parallelogram. Now there are some properties of parallelogram. Now in parallelogram both pair of opposite sides are parallel, but in this both pair of opposite side is equal also. That is AB is equal to CD and AD is equal to BC. Okay, so in a parallelogram opposite sides are equal. Opposite angles are also equal. Okay, so in a parallelogram opposite sides are equal and opposite angles are equal. There is one more property. The property is the diagonals of a parallelogram bisect each other. What does it do? It bisect each other. That is, this OA is equal to OC and OB is equal to OD. Okay, so there are 3 properties. First one is the definition. Definition, you know that the opposite side, both pair of opposite sides of a parallelogram are equal. Then opposite sides are equal. Opposite sides are also equal, and diagonals bisect each other and opposite angles are equal. Okay, so these are the properties of the parallelogram. Now come to the rhombus. Next one is what? Rhombus. Rhombus is a parallelogram. Okay, rhombus is a parallelogram, but some special property. Rhombus is like this. If I draw this one, this is A, B, C and D. So I am writing A, B, C, D. So this is a parallelogram. First of all, the parallelogram, opposite sides are parallel, opposite sides are equal, opposite angles are equal, and diagonals bisect each other. Each and every property of parallelogram applies in rhombus. But there are some special property in this. What? All the sides of a rhombus are equal. Okay? This. All sides. AB is equal to BC, BC is equal to CD, and CD is equal to DA. So all the sides of a rhombus are equal. And there is one more property, that the diagonals of the parallelogram bisect. But the diagonals of the rhombus bisect each other at 90 degree. That is, they make here at 90 degree. What they make? They make an angle of 90 degree at the point of intersection. So a rhombus is a parallelogram whose all sides are equal. And the diagonals bisect each other at 90 degree. Okay. Now the next one. Next one is what? Rectangle. Next one is rectangle. Rectangle is also a parallelogram. It is drawn something like this. This way. If I draw like this. This is P, Q, R and S. So rectangle is a parallelogram. That is, all properties of parallelogram applies in this rectangle. That is, opposite sides are parallel, equal, opposite angles are equal, and diagonals bisect each other. But in this also there is some special property. And what is that? That is that the interior angles, these interior angles are 90 degree. What they make? They make an angle of 90 degree. So rectangle is a parallelogram in which at least one angle, if one angle is each and every angle, at least one angle is 90 degree, interior angle, then it is a rectangle. And there is one more property of rectangle. Its diagonals bisect each other. Diagonals bisect each other. But the diagonals, that is PR and QS of rectangle, are equal. What? The diagonals of the rectangles are equal. So the diagonals of a rectangle are equal. So rectangle is a parallelogram in which at least one angle is 90 degree and the diagonals of the rectangles are equal. Okay, and all the properties of parallelogram applies in rectangle. That is, opposite sides are parallel, equal, opposite angles are equal, and diagonals bisect each other. Except this, there are other properties also. That is, this interior angles are 90 degree and diagonals are equal. Okay, now the next one. So what is the next one? Next one is a square. Okay, after this it is a square. So square is also parallelogram. Actually square is also a rectangle, and square is a rhombus also. Actually square is something which has all the properties of parallelogram, rectangle and rhombus. Okay, and it is something like this. So in this, what it is? It is a, suppose I am writing P, Q and R, S. This is a square. So this is a square, means it is a parallelogram also. That is, opposite sides are parallel, opposite sides are equal, and diagonals bisect each other. All the properties. What is rhombus? Rhombus is a parallelogram, but all sides are equal. So in a square it is also all sides are equal. Okay, and the diagonals bisect each other at 90 degree because the square is a rhombus also. It applies all the properties of the rhombus. So diagonals bisect each other at 90 degree and all the sides are equal. Now square is a rectangle also. How? Because in a square these interior angles are what? 90 degree. These interior angles are what? 90 degree. And the diagonals of a square are equal. Diagonals of a square are equal. Okay, so square is a quadrilateral in which there are properties of parallelogram also, rectangle also and rhombus also. Okay, last but the not least is So last but not the least is kite. Okay, so kite is also quadrilateral and it is different from all these. A kite is a quadrilateral in which any two pair of adjacent sides are equal, like this. If I draw this and this, so this is A, B, C and D. So a kite is a quadrilateral in which any two pair of adjacent sides, like AB is equal to AD, this, okay, and the next one is BC is equal to CD, this. So any two pair of adjacent side is equal. So it is a kite. In kite, now this is a diagonal and this is a diagonal. So in kite, diagonals doesn't bisect each other. In this diagonal AC bisect the BD and they bisect at 90 degree. Okay, this much only. So all these are the properties of the quadrilaterals and all this. Okay, and we have the use of this in constructing the quadrilaterals. What is the use? The use is, now suppose if you want to construct a quadrilateral, so minimum how much condition should be there to construct a quadrilateral? Because if we construct a triangle, it needed minimum 3 conditions. But for constructing the quadrilateral, we need minimum 5 conditions to construct a quadrilateral uniquely. How many conditions? 5 conditions, minimum 5 conditions, and that 5 condition depends what are these. Okay, so we need 5 conditions. But when we have the special types of quadrilaterals, then these conditions minimize. Okay, like if we just want to draw the parallelogram, so we need only minimum 3 conditions. What? Minimum 3 conditions, and the rest condition we can find out by the properties. For constructing rhombus and rectangle, we need 2 conditions. How many conditions? 2 conditions for constructing rhombus and rectangle. And for constructing a square, we need just 1 condition. And the other conditions we can find out by the properties. Okay, so these are the uses in constructing the quadrilaterals. Okay, so questions like comes that how many conditions needed to construct a quadrilateral uniquely? Answer is 5. Now the next question is how many conditions needed to construct parallelogram uniquely? 3 conditions. Then how many conditions are needed to construct a square uniquely? Only 1. And how many conditions are needed to construct rhombus or rectangle? Then how much? Only 2 conditions. Okay, so just revise all this. In the next video, in the next class, we'll discuss how to construct the quadrilaterals and what are the conditions to construct a quadrilateral. Okay, till then, goodbye. Have a great day. Take care.